सो इनडिटर्मिनेट फॉर्म्स में अब हमारे पास एक ही इनडिटर्मिनेट फॉर्म बची है, दैट इज़ इन्फिनिटी टू द पावर 0। सो आज के वीडियो में हम पावर इनडिटर्मिनेट फॉर्म ऑफ द टाइप इन्फिनिटी टू द पावर 0 देखेंगे। एंड फ्रॉम द प्रीवियस वीडियोज़ वी नो when we are computing the limiting value of a function such that we are having this form limit x approaches to fx to the power gx, then this form is said to be a power indeterminate form of the type infinity to the power 0 if fx infinity को जाएगा and gx tends to 0, then this form will be called infinity to the power 0 type. And we also know the working rule to arrive at the solution for this power indeterminate form. First of all, we convert this power indeterminate form, and this is also valid for other power indeterminate forms. हम पहले इन power indeterminate forms को 0 into infinity type में convert करते हैं, and then वहाँ से 0 by 0 form या infinity by infinity form में convert करके वहाँ से L'Hopital rule apply करते हैं। Now if we wish, we can also cut the long story short by directly converting the power indeterminate form into 0 by 0 form or infinity by infinity form. That means कि जो middle step है 0 into infinity, we can avoid that step, and this middle step, this can be avoided by the relation. We can convert this power indeterminate form into 0 by 0 form or infinity by infinity form by the relation log of fx divided by 1 over g of x or gx divided by 1 over log of x, but we always prefer the function with log in the numerator. And again it comes to the point कि क्यों है infinity to the power 0 एक indeterminate form. So why is infinity to the power 0 an indeterminate form? And note that 0 raised to power infinity is 0, so that means this is a determinate form, while infinity to the power 0 is an indeterminate form. So अगर हम condition चेक करें infinity और 0 की, so since infinity is an exceptional value जिसका एक हम exactly value नहीं बता सकते, but we can at the same time say कि infinity एक बहुत ही बड़ा number है. So as such इन्फिनिटी का कोई भी पावर एक बहुत ही बड़ा नंबर होना चाहिए था, बट देन अगर हम पावर की कंडीशन चेक करें, सो वी नो कि कोई भी नंबर व्हेन रेज्ड टू द पावर 0 दैट रिजल्ट्स इन 1, सो विथ एक्सेप्शन एज 0 बिकॉज वी प्रीवियसली हैव स्टडीड कि 0 रेज पावर 0 एक इनडिटर्मिनेट फॉर्म भी है। और इन्फिनिटी की कंडीशन चेक करें यहाँ पे, सो इन्फिनिटी की कंडीशन चेक करें, सो इट शुड हैव बीन ए मच बिगर नंबर, बट व्हेन वी चेक द कंडीशंस ऑफ द पावर दैट इज 0, सो इट शुड बी रिजल्टिंग इन 1। सो यहाँ से इन्फिनिटी और यहाँ से 1, सो दैट मीन्स एग्जैक्टली नहीं बता सकते कि कहाँ जाएगा। सो इन्फिनिटी टू द पावर 0 इज दस एन इनडिटर्मिनेट फॉर्म। सो इन्फिनिटी टू द पावर 0 इनडिटर्मिनेट फॉर्म्स को लेके कुछ एग्जाम्पल सॉल्व करते हैं। एंड फर्स्ट एग्जाम्पल इज लिमिट x टेंड्स टू पाई बाई 2 10 x रेज पावर साइन 2x, and when x tends to pi by 2, this will be 10 pi by 2, 10 pi by 2 is infinity, and sine 2 into pi by 2, 2 से 2 cancel होगा, so it will be sine pi is 0, so that means this is a power indeterminate form of the type infinity to the power 0. So limiting value हम already जानते हैं कि हम कैसे निकालते हैं। So first of all इस power indeterminate form को हम 0 into infinity type में convert करते हैं, और 0 into infinity type में convert करने के लिए so we take log on both sides. So we write let y is the limiting value of this limit, so limit x approaches to pi by 2 10 of x raised power sine 2x. So taking log both sides, so it will be log of y is equal to, and we know log of limit is limit of log, so it will be limit x tends to pi by 2 log of 10x raised power sine 2x, which is equal to limit x tends to pi by 2 और log of 10 of sin 2x is sin 2x आगे multiply होगा, so it will be sin 2x into log of 10x, because we know log of a raised power b is b log a. Now this is reduced to 0 into infinity type, because we know sine pi, when x का value pi by 2, so sine 2 into pi by 2, so pi 2 से 2 cancel होगा, so it will be sine pi, and log of tan pi by 2, tan pi by 2 is infinity, so this will be still log of infinity, and that is again infinity. So this is reduced to 0 into infinity type. अब यहाँ से 0 into infinity type को हम 0 by 0 form या infinity by infinity form में convert करेंगे. So it will be limit x tends to pi by 2, and when we convert it into 0 by 0 form or infinity by infinity form, so we should prefer कि log वाली function ऊपर numerator में ही रखें और दूसरी function नीचे लाएं. So it will be log of 10x divided by 1 over sine 2x, which can be again written as limit x tends to pi by 2. So this will be log of 10x, और 1 by sine 2x को हम ऐसे भी लिख सकते हैं cosec 2x. Now this is reduced to infinity by infinity form. Now applying L'Hopital rule, we can write this as, so this will be limit x tends to pi by 2, limit x tends to pi by 2 log of 10x की differentiation. So first of all 1 by 10x into 10x की internal differentiation, that will be sec square x divided by, so cosec 2x की differentiation, that will be minus cosec 2x into cot of 2x, or 2x की internal differentiation, that will be 2. And next we can simplify this as limit x tends to pi by 2. So 1 by 10x is cot x. अब cot x को हम ऐसे भी लिख सकते हैं cos x divided by sin x into, and sec square x can be written as 1 divided by cos square x divided by minus cosec 2x को ऐसे लिखेंगे 1 divided by sin 2x, because we know cosec and sin are reciprocals, into cot of 2x into 2. And simplifying further, this will be limit x tends to pi by 2. अब cos से a cos cancel होगा, so that means ऊपर वाले सेक्शन में, so it will be 1 divided by, ये sin x रह गया, sin x into cos x divided by minus 1 divided by sin 2x, and we know sin 2x की double angle formula, that will be twice sin x into cos of x into ऊपर cot of 2x into 2. अब 2 से ये 2 cancel होगा, and next we'll be writing limit x tends to pi by 2, 1 divided by sin x into cos of x, और इस चीज़ का reciprocal with minus, that will be sin x into cos of x divided by cot of 2x, and next sin से sin cancel होगा और cos से cos, so that means we will be left with limit x tends to pi by 2, 1 divided by cot of 2x, which is limit x tends to pi by 2, and cot of 2x अगर ऊपर ले आएंगे as reciprocal, so this will be tan of 2x. अब limit use कर सकते हैं, that means it will be tan of 2 into pi by 2, so this is tan pi, and tan pi is 0. So which means log of y is equal to 0. So taking e as the base, so it will be e raised power log of y is equal to e raised power 0, which means y is equal to 1. So next example is limit x tends to 0 cosec x raised power 1 by log x, and this is infinity to the power 0 form. So writing let y is the limiting value of this thing, so let y is equal to limit x tends to 0 cosec x raised power 1 by log of x, taking log both sides. So log of y is equal to, and we know log of limit of a function is limit of log of that function, so it will be limit x tends to 0 log of cosec x raised to power 1 by log of x, And next we can write this as limit x tends to 0 or 1 by log of x आगे multiply होगा. So it will be log of cosec x divided by 1 by log x. So it will be log of x. Now this is reduced to infinity by infinity form. So applying L'Hopital rule, this will be limit x approaches to 0. So log of cosec x की differentiation 1 divided by cosec x into cosec x की internal differentiation cosec x into cot of x divided by log x की differentiation 1 by x. cosec x से ये cosec x cancel होगा. So next this will be limit x tends to 0. So ऊपर cot of x और ये 1 by x reciprocal लेके as x divided by 1. Now when we see x into cot of x, so this is not any particular indeterminate form और directly limit use भी नहीं कर सकते क्योंकि when x approaches to 0, so cot 0 is undefined, so this whole thing will turn out to be undefined. और यहाँ पे minus रह गया, so this will be minus cot of x. So but we can write this as limit x tends to 0. अगर हम cot का reciprocal ले, that will be tan, so it will be 1 divided by tan of x into x. That means this is now limit x approaches to 0. So this will be x divided by tan of x, and we know इस value इस limiting form का limiting value -1. So this will be -1 क्योंकि ये सारी चीज़ किसके बराबर 1. So this is special limit. So this is -1. That means log of y is equal to -1. So taking e as the base, so e raised power log of y is equal to e raised power -1, which means y is equal to e raised power -1 or y is equal to 1 by e. Next example is limit x tends to 0, 1 divided by x raised power m raised power x raised power n. And this is again infinity to the power 0 indeterminate form. So again writing let y is a limiting value, let y is equal to limit x tends to 0, 1 divided by x raised to power m whole raised to power x raised to power n. So taking log both sides, so log of y is equal to log of limit is limit of log. So this will be limit x tends to 0, log of 1 divided by x raised to power m into x raised to power n, which is equal to x raised power n आगे multiply होगा x tends to 0 x raised to power n, and this can be written as log of, अगर हम x raised power m को ऊपर ले आए then it will be x raised to power minus m. So this is 0 into infinity type now. So that means we'll be converting this into 0 by 0 form or infinity by infinity form. So this will be limit x tends to 0, log of x raised to power minus m divided by 1 divided by x raised to power n. And this will be limit x tends to 0, log of x raised to power minus m divided by, अगर हम x raised power n को ऊपर ले आए then in that case it will be x raised power minus n. So applying L'Hopital rule, this will be limit x tends to 0, limit x tends to 0 and log of x raised power minus m के differentiation 1 divided by x raised to power minus m, and then x raised power minus m के internal differentiation it will be minus m into x raised to power minus m into x raised to power minus 1 divided by x raised power minus n के differentiation minus n into x raised to power minus n into x raised power minus 1. अब -1 से ये -1 कैंसिल होगा, माइनस से ये माइनस, सो m by n बाहर आएगा. सो इट विल बी m by n into limit x approaches to 0. सो x raised power minus m से ये x raised power minus m कैंसिल होगा. सो दैट मीन्स इट विल बी ओनली 1 divided by x raised to power minus n. So next we can write this as m by n limit x tends to 0, x raised power minus n ऊपर आएगा, so it will be x raised power n. And when x approaches to 0, so this whole thing will be 0. So log of y is equal to 0 implies y is equal to 1.